What? I try to do divide and conquer for every single one of these questions. Yeah, between the switch and the servers, that's just like obviously a data link problem. Or if it's not a data link problem, it's definitely on the lower end of the OSI model, so it doesn't make sense to do anything else. Did my headphones disconnect or did the music just pause? Oh well. What is happening? Come on. What are we doing? Unintentional source? I see. I mean, if the SSID is being advertised... Okay. where each computer acts as a client. Would that be a peer-to-peer network? That one had stupid distractors. Valid shortened forms, so it's not one, because you can't have two double colons. This one, you can remove leading zeros. You just have a single double colon. I mean, they could have removed these. They could have just done 0. But I mean, I think this is probably valid. This one, you can't do double colons. Oh, these are identical. That sucks. Oh no, this one? Okay. They were identical, I can move. That was my bad. Precision time protocol. Nanosecond precision. The expected 100 megabits. The network uses switches and all devices support fast Ethernet. What could the network admin enable to improve the data transfer rates to the expected 100 megabits? I don't know. This seems like a pretty old, like, expected 100 megabits. Like, nothing is 100 megabits now. So this seems old enough to where, like, oh, where like the option between half duplex and full duplex is like a option to make. So like that inclines me toward 3. It's definitely not 2. It's definitely not 4. So it's either 1 or 3. I'm gonna go for... I actually remember like a question like this having the answer with auto negotiation. So I think I'm gonna go for this one, but it could be full duplex. Okay. All right. During periods of high traffic. I should have gone with my gut on that last one. It was discovered that during periods of high traffic, critical data packets from a real-time trading application were experiencing delays leading to financial losses. The IT department has been asked to ensure that these critical packets are given priority over other network traffic, such as email and web browsing, without increasing infrastructure costs. Are given priority over other network traffic. That would be traffic shaping. In RIP. What is RIP? Router Information Protocol? I've written a note about it. Okay. Routing information protocol. Receives an update that includes a route to a network that it already knows about. Sure. Do I have a no on routing information protocol? Mention this explicitly. Um, 1988. Dude.
Hello everyone, in this video we're going to be talking about routing tables. The internet is a giant highway of pathways for data to travel to their static and dynamic. So let's first talk about directly connected routing tables. So here we to its destination. So a routing table is simple.
Maybe I should watch this.
Hello everyone, in this video we're going to be talking about routing tables. The internet is a giant highway of pathways for data to travel to their destination. And in between these pathways are devices called routers. And routers, just like its name says, routes data on the internet so that the data can reach its destination. And routers route data by using routing tables. A routing table is a file that contains a set of rules that shows information on what path a data packet takes to its destination. So as a data packet arrives at the router will look at its routing table to find out where to forward the data packet along the best path to its destination. So a routing table is similar to a roadmap or a navigation for your car. If you were traveling to a certain destination anywhere in the world, so for example on vacation, you will most likely need directions or a map on how to get from point A to point B. Well, in the world of networking, it works the same way. In order for data to travel across the network and reach its destination, it needs directions to determine how to get there. Routing tables are populated in three ways, which are directly connected, static, and dynamic. So let's first talk about directly connected routing tables. So here we have two networks, and the networks are separated by a router. And each network is using a different IP address group, with the computers having their own IP address. This network
I'm gonna use Opus for this one. Yes, it does.
This network is using the 192.168.0.0 IP address group, and the other network is using the 10.0.0.0 IP address group. So right now, the computers in each network can only communicate with the computers inside their own network. However, in order for the computers on these networks to have the ability to communicate with the computer on the other network, we have to configure the router and a routing table, because a router has the ability to allow communication between networks. So this router is using two interfaces. One interface, labeled Ethernet 0, is connected to the 192 network, and the other interface, labeled Ethernet 1, is connected to the 10 network. So we will go ahead and configure this interface and give it an IP address and subnet mask in the 192 IP address group. And then we'll configure the other interface for the 10 IP address group. And when we do this, the router is going to automatically create a routing table with directly connected routes. Directly connected routes show the routes for the networks which are directly connected to an interface. So now if we look at this routing table, it's informing the router that any packet intended for the 192 network will be forwarded out this interface. And likewise, any packet intended for the 10 network will be forwarded out this interface. So now, when a computer on the 192 network wants to communicate with a computer on the 10 network, the computer will send a data packet to the router, and when the router receives the packet, it'll look at the destination IP address of the packet, which is 10.0.0.2, and refer to its routing table to determine where to send the packet. So the router will look at its routing table and see that this packet is intended for a device on the 10 network and will forward the data out this interface, and then to the intended computer. So this is basically how a routing table works. So in another example, let's add another interface to this router. And let's go ahead and connect another router and another network with computers to this setup. And this network up here will be using a different IP address group of 174.16.0.0. And also, the interfaces between these two routers also need their own IP address group so that the routers themselves can communicate with each other. So we'll give them a separate IP address group in the 125.0.0.0 network. Now, just to clear things up, any link between routers is considered a separate network, regardless if there are computers in the network or not. So in reality, we actually have 4 networks here. So now, since we have configured the routers with an IP address and subnet mask, if we look at the routing table for this router, we'll see that it has an additional directly connected route. And we see that the Ethernet 2 interface is directly connected to the 125.0.0.0 network. And if we pull up the routing table for this router up here, we'll see the directly connected routes that are connected to this router's interface. The 174 network is connected to Ethernet 0, and the 125 network is connected to Ethernet 1. So now, let's say that this computer here on the 192 network wanted to communicate with this computer up here on the 174 network. So this computer will send a data packet to the router, and when the router receives the packet, it'll look at the destination IP address of the packet, which is 174.16.0.2, and refer to its routing table to determine where to send the packet. But the problem is that the directly connected routing table doesn't refer anything to the 174 network. Because remember, directly connected routing tables only show networks that are directly connected to the router. So since this router can't find the 174 network, the router thinks that the 174 network doesn't even exist. So the router would just drop the packet. So what do we do here? Well, this is where we need to add an additional route to the routing table, such as a static route. Static routes are manually configured by a network administrator. So we need to log into this router and manually create a static route so that the router knows where to find the 174 network. So to create a static route, we need to log into this router, and since we want the 192 network the ability to communicate to the 174 network, we need to add the 174.16.0.0 network along with the number of bits in the subnet mask, and then we need to add the IP address of the interface of the next hop or step that this router needs to take to get to the 174 network. So the next hop that this router has to take is this IP address here, which is 125.0.0.2. So now, when this computer on the 192 network wants to communicate with a computer on the 174 network, the computer will send a data packet to the router, and when the router receives the packet, it will look at the destination IP address, which is 174.16.0.2, so the router will see that there is a static route in the routing table for the 174 network, and it will forward the packet to the next hop, which is 125.0.0.2. So now this router has the packet, and this router will now look at its own routing table and look at its directly connected routes and see that the 174 network is directly connected to this interface, which is Ethernet 0. So the router will now forward the packet out this interface, which will reach the destination computer. So now any computer on the 192 network can communicate with any computer on the 174 network. However, it can only communicate in one direction, because in order for the 174 network to communicate back to the 192 network, we have to configure a static route in the other direction also. So now we have to log into this router and create a static route so that the 174 network can talk back to the 192 network. So for the network, we type in the destination network, which is 192.168.0.0, and for the next hop that this router needs to take to get to the 192 network will be this IP address here, which is 125.0.0.1. So now both networks can communicate with each other in both directions. But what about communication between 174 and the 10 network? Well, the 10 network is able to communicate with the 174 network in this direction, because earlier we created a static route that informed this router on how to get to the 174 network. But the 174 network can't communicate back to the 10 network because we haven't informed this router where to find the 10 network. So let's go ahead and log back into this router and create a static route so that this router knows where to find the 10 network. So for the network, we'll type in the 10.0.0.0 network, and for the next hop or interface, it's this IP address here. And now all the networks can communicate with each other in all directions. Now let's talk about a third way that a routing table is populated, and this is dynamic routes. Dynamic routes are similar to static routes, but the difference is how the routes are entered into the routing table. So where static routes are entered manually, dynamic routes are entered automatically by neighboring routers, and they do this by using one or more dynamic routing protocols. These dynamic routing protocols are RIP, OSPF, BGP, ISIS, and EIGRP, which I will make a separate video talking about these protocols. So as an example, if we got rid of the static routes that we created for these routers and instead configure them with a dynamic
Static routing requires the network administrator manually configure every route on every router in the organization. If you have 3 or 4 routers, that might not be a big problem. But if you have tens or even hundreds of routers, you might want to have a more automated way for configuring your routing tables. One way to do that is through the process of dynamic routing. Dynamic routing will have the routers handle this process for you, automatically discover these routes, and update each other as to where the best route might be. This means that you as the network administrator don't have to do any type of static route configuration. You don't have to SSH into the router, make any configuration changes, or update those routes if anything changes with your network infrastructure. Anytime you bring a new router online, all of the other routers will this update. They need to interpret this information and determine if that's a better route than what they already have, or if they should
Let's dive into a look at the theory of RIP. One of the dynamic... Let's dive into a look at the theory of RIP. One of the dynamic routing protocols you need to know about for the Network Plus exam is RIP, which stands for Routing Information Protocol, and there are a few different versions I want you to know about. First up is RIP version 1, or RIP v1. By the way, I would not use this on a modern network. I actually did use this on a network at a university way back in the early 1990s, but I would certainly not use it today. It's got some undesirable characteristics. For example, the way it sends out routing information to other routers is through broadcasts. Now remember, a broadcast goes to every device within a subnet or within a broadcast domain. That means when the router says, here's my routing table, I can get to all of these networks, that advertisement goes not just to neighboring routers, routers, it goes to PCs and printers and every other device in that subnet. And to compound that, it happens by default every 30 seconds. It's like me coming up to you and saying, hey, let me read you my resume of everything I know how to do. And I read this resume and I come back 30 seconds later and I do it again. And 30 seconds later and I do it again. That's a bit much. And another downside to RIP version 1 is it does not have what is called VLSM support. For your notes, that stands for variable length subnet masking. What that's telling us is that RIP version 1 can only advertise classful networks, meaning that if we go in and add some bits to a subnet mask to take one network and divide it up into different subnets, if we do that, we cannot advertise those networks that we created by adding bits. We have to advertise at that classful boundary. So let's say you take the 10.1.1.0 network and you've applied a 24-bit subnet mask. If you tell RIP to advertise that, it's going to say, nope, I'm just going to advertise the classful address for a 10. Network, which has 8 bits in the subnet mask. RIP version 1 also only supports IP version 4. Now things did get a lot better with RIP version 2. Instead of sending its advertisements everywhere, a RIP version 2 router is a bit more selective. It's going to use a multicast, which is going to go just to RIP version 2 speaking routers, because those routers join a multicast group with a group address of 224.0.0.9. This version does support variable length subnet masking. It also adds authentication, so you cannot have someone just bring up their own router.
I'm going to use the restroom really fast. for each Ethernet network interface. Would that be a MAC address? Because it's a network interface card, right? It contains more than one route to the same destination prefix. What happens when a routing protocols database contains more than one route to the same destination? That would be the path with the lowest cost metric. What does the TTL value in the ping command output indicate? In the ping command? Time to live. I know that in trace route it's the number of hops, which is a little funny. Or is it the number of hops in ping too? Because the other ones aren't correct at all. I did not need a dash there. Sure. I see. The perimeter security model. Oh, sure. Yes, I remember getting that one wrong in the past. I think I did that same wrong answer. Perimeter. I'll get the question again. What is the purpose of a business impact analysis in continuity planning? Security group have regarding what property does the security group have regarding its filtering rules? Stateful. Perimeter secure. Voice over IP endpoint be implemented as. Border gateway protocol and share routes with other internet routers. border gateway protocol on your company network and share routes with internet routers. Really? Do I have anything written on border gateway protocol?
The White House finally admitted it. Our country is under attack and we need to secure our border. No, I'm not talking about the northern border to keep Canadians out. I'm talking about the Border Gateway Protocol, one of the fundamental pillars holding up the internet and global economy with updated hope. Back in 2008, YouTube went down across the entire world and we were deprived of media for hours, all because some government official in Pakistan messed up a config value when trying to censor the internet. In 2018, Amazon Route 53 DNS traffic was hijacked and wiped out the life savings of a bunch of crypto bros. Then in 2021, yet another misconfiguration took out Facebook and Insta for multiple hours. The world began to heal, but unfortunately they fixed it and came back online. And on multiple occasions, China and Russia have intercepted US internet traffic. But none of these incidents should have ever happened. In today's video, you'll learn exactly how the Border Gateway Protocol works, why it's broken, and the plan to fix it. It is September 11, 2024, and you're watching the Code Report, a Jenga tower of protocols. And one of the most sketchy pieces in that tower is something called the Border Gateway Protocol. The internet is made up of a collection of networks that work like their own autonomous systems. Like an ISP, big corporation, or government agency might all have their own networks. And BGP allows them to announce two things: that the network exists and which networks can be reached by them, allowing routers to automatically decide the most efficient path to take. It's almost like the post office of the internet. At the global level, individual IP addresses get grouped together into prefixes, and then routing tables between anonymous systems are maintained by the Border Gateway Protocol. Like, for example, all the traffic coming out of Verizon routers is one autonomous system, and all the traffic coming from AT&T is another. These networks are all connected together by routes, and this diagram shows how BGP helps them find the most efficient route to take in order to send packets between these networks. That's all good, but the problem is that this thing was designed 25 years ago, before stranger danger was a thing, and before guys like Hans Gruber warned us of a global cyber attack. For one, it doesn't check to see whether a remote network announcing a traffic path change.
This isn't informative enough.
Okay, BGP is the Border Gateway Protocol, and it's a routing protocol that evolved in the internet, and you can think of it as kind of the top of the food chain in terms of routing in the internet. It's the protocol that's used to connect the service providers, let's say, primarily in the internet. So how does AT&T exchange reachability information with BT, with France Telecom, and they have to exchange this kind of reachability information so that we can glue these autonomous networks together, because there is no centralized control in the internet. So BT controls its equipment and it's part of the internet, but AT&T controls its own part of the internet, and they have to interoperate somehow. They have to be able to exchange information about the IP addresses associated with their customers, etc. So the Border Gateway Protocol, BGP, is this protocol that has evolved to handle that job, right? To exchange information between autonomous networks, okay? So without any centralized control. There are many interesting engineering problems there, interesting research problems in terms of scalability and robustness, etc. But I'm going to talk about it in really sort of elementary terms, and I want to talk about a simple graph problem, a sort of reachability problem in graphs, in simple combinatorial graphs where we have nodes and arcs, and we want to get from one place to another. You send a packet to your service provider, it has to look in a table and figure out where to send that next. And that packet may end up on the other side of the globe in a completely different network. And so it's that level, it's how to get from here to there.
So it's the foundations of the internet.
It's the basic global foundation of the internet. Different protocols are used within these autonomous networks, and I think Mort talked about that in a previous computer file. And for example, you might use some kind of shortest path based thing within a network. But between networks, what's interesting about this is that we want this interdomain, I'll call these domains or regional autonomous networks. We want this routing to interoperate, to work, even when the service providers don't have common agreement about what is the best route, for example. Your best route might not look like my best route because we have different contracts with different companies in the internet, and so we will have different ideas about what is best. Okay?
So that might be a commercial thing. It might be, I don't want you to send too much traffic through me because it's going to cost me money to run.
That's right. And basically, the idea is that when you're doing shortest path routing, you want everybody to be connected with everybody and along the shortest path. And in the internet, you don't want traffic to be crossing your network unless somebody's paying you for that, either the source of the traffic or the destination or a combination, right? Somehow. And so in other words, common agreement about what is the best route, for example. Your best route might not look like my best route because we have different contracts with different companies in the internet, and so we will have different ideas about what is best. Okay?
So that might be a commercial thing. It might be, I don't want you to send too much traffic through me because it's going to cost me money to run.
That's right, right. And basically, the idea is that when you're doing shortest path routing, you want everybody to be connected with everybody and along the shortest path. And in the internet, you don't want traffic to be crossing your network unless somebody's paying you for that, either the source of the traffic or the destination or a combination, right? Somehow. And so, in other words, the protocol is more about limiting the connectivity rather than being generous about it and giving it to everyone. It's kind of, let's restrict this connectivity to those that are paying for it somehow. That's basically the idea. But what I want to think about is, well, how does this fit into our notion of finding paths in a graph? Because in undergraduate computer science, one of the things we teach in algorithms courses is a lot of shortest path algorithms. So we define a graph, let's say, that is nodes and arcs, and you have a weight on these arcs, and then you try to find the best path between every pair of arcs, let's say. And we typically teach this, and we teach lots of algorithms for doing this, like Dijkstra's algorithm, Bellman-Ford, Warshall's algorithm. So can we abstract away from the complexities of BGP and think about it in those terms? The thing is, it doesn't quite fit in our models very well, and I'll try to explain informally why not.
What doesn't fit? The BGP, or what doesn't fit?
Okay, so we normally think about shortest path in terms of numeric values. Okay, so, and we typically add those values as we go along a path, right? So maybe each arc has a weight 1. And we essentially count the number of hops that we're going through a path, and then we would prefer, let's say, a shorter path, one with fewer hops, than a longer one. So what we're using there are two operations, plus, and maybe an operation, let's call it min. Okay? So we have these operations, min and plus.
So min for minimum,
yeah,
plus for adding up those hops, yeah?
Right. And so what people noticed at about 40 years ago is that a lot of these algorithms that we have for shortest paths, Dijkstra's algorithm, Bellman-Ford, can be generalized to a large class of algebraic structures called semi-rings.
I'm going to ask you what is a really stupid question, I'm sure.
Okay.
Semi-ring. I'm not familiar with a semi-ring.
Okay, so a semi-ring is an algebraic structure that looks like a ring. So what is a ring? A ring is something like the real numbers. So we have a domain, the real numbers, and we have a plus and a times. They are plus and times the standard operations. Linear algebra is built on rings, right? We take matrices, we multiply matrices, we solve matrix equations, things like that. That's all linear algebra. Well, it turns out that semi-rings and...
What? Dude, it's over. Dude, I know nothing about this. Bro.
And routing is also, it's kind of like a generalization of that, where we weaken the properties that the plus and the times have to have, right? So for example, a ring, that plus has inverses. We have negative numbers. So there's always for every a, there's a negative a that when you add them together, you get 0. Okay? And a semi-ring is like a ring, except it doesn't have that inverse property. You don't necessarily have inverses. What people did back in the 60s and 70s is they looked at algorithms like Dijkstra's algorithm, like Bellman-Ford, and then they said, wait a minute, let's work backwards. Let's look at these. We see min and plus in the algorithms, but let's replace them by abstract operators. And let's see what algebraic properties we need to make this algorithm work still. Suppose we want to pick paths that have the highest capacity. Okay? So we might, instead of using plus, we might go along a path using min. The weight of a path will be the minimum capacity link. And then instead of using min to compare paths, we might want to use max. So that would give us the highest capacity path. Okay? So people noticed, oh, wait a minute, this min plus path using abstract operators. And let's see what algebraic properties we need to make this algorithm work still. Suppose we want to pick paths that have highest capacity. Okay? So we might, instead of using plus, we might go along a path using min.
Pick paths that have the highest capacity.
The weight of a path will be the minimum capacity link, and need to make this algorithm
I don't think that thing is
Suppose we want to pick
intentional.
paths that have the highest capacity. Okay, so we might, instead of using plus, we might go along a path using min. The weight of a path will be the minimum capacity link, and then instead of using min.
Sure. It's like across these connection points, you have like a minimum amount of capacity, and so if you want to do the path with the highest minimum capacity, that makes sense. Okay, sure. I see what you're saying.
We might want to use max. So that would give us the highest capacity path. Okay, so people noticed, oh, wait a minute, this min plus and this max min, they have certain algebraic properties that are true. And we can take Dijkstra's algorithm and we can replace the plus with min and replace the min with max. And now we have an algorithm that it works perfectly fine. Now it finds the highest capacity paths in the graph. And then we can build other things. For example, suppose I wanted to find paths that were shortest, but if I had two paths that were equally short, maybe I want to break ties with capacity. Okay? So then now I could have a path with two metrics, distance, capacity, right? And then I could essentially use shortest paths on that first component and then break ties with capacity. Okay? That too, and now it finds the highest capacity paths in the graph. And then we can build other things. For example, suppose I wanted to find paths that were shortest, but if I had two paths that were equally short, maybe I want to break ties with capacity. Okay? So then now I could have a path with two metrics in the graph. And then we can build other things. For example, suppose I wanted to find paths that were shortest, but if I had two paths that were equally short, maybe I want to break ties.
Oh, sure. So you would like differentiate them. So like, if you're trying to differentiate them with hops, but then the hops are the same, you can have like a second criteria that only like turns on if the criteria is the same for both things. So like, oh, you would, okay.
Ties with capacity. Okay, so then now I could have a path with two metrics, distance,
Sure.
capacity, right? And then I could essentially, use shortest paths on that first component and then break ties with capacity. Okay?
Right.
That too, that turns out you can make a semi-ring out of
Break
this.
ties. Like you have a tie, you break the tie. Okay.
And guess what? You can use Dijkstra's algorithm, Bellman-Ford, to compute with these as well. If you compare things, first distance, then capacity, it's kind of a lexicographic comparison there. You can build a semi-ring out of that, and then so these algorithms.
Lexicography. Lexicography is the study of lexicons and the art of compiling dictionaries. How is this lexicographic?
Semi-ring out of this, and then guess what? You can use Dijkstra's algorithm, Bellman-Ford, to compute with these as well. If you compare things, first distance, then capacity, it's kind of a lexicographic comparison.
Oh, wait, I could do this. Well, sure. This is similar to how words are ordered in a dictionary. You compare the first letter, then the second letter if the first letters are the same, and so on. Why not just say it's hierarchical? I probably spelled that wrong. Hierarchical. I can't fulfill that type of request. Awesome.
You can build a semi-ring out of that, and so these algorithms are really generic. You can just plug in, just an unbounded number of different algebraic structures to get what you want, and use the same algorithms, Bellman-Ford or Dijkstra, etc. So this might seem like, oh, now we have this open-ended world. Maybe we can model something like BGP in this world. Turns out we can't. Okay. And let me give you an example of it that's easier to understand than BGP. Okay. I told you we could do. We could look at distance first, then break ties with bandwidth. Or capacity. Let's suppose we did it the other way around. I want the highest capacity paths, and if I have two best paths with high capacity, I want to break ties then on the distance. So I first look at the capacity component, then I break ties on distance. That's not a semi-ring anymore. Why is that? Oh, it's not obvious that if you use some of these generic best path algorithms, something's going to break, maybe. Why is that?
He is balding, but he does have pretty good hair.
Obvious, but it turns out that one of the rules that needs to be followed by a semi-ring is something called distributivity. This is an algebraic property. What it really means is that it doesn't really matter if I make a decision about the best paths, seeing all my paths, or you, my neighbor, you make the decisions and you tell me what your best path is. It kind of doesn't really matter.
Because we'll come to the same.
We'll come to the same conclusion, right? So that's what distributivity is all about.
Sorry, I was saying
obvious, but I want the highest capacity paths, and if I have two best paths with high capacity, I want to break ties then on the distance. So I first look at the capacity component, then I break ties on distance. That's not a semi-ring anymore. Why is that? Oh, it's not obvious that if you use some of these generic best path algorithms, something's going to break, maybe. Why is that? not obvious, but it turns out that one of the rules of, that needs to be followed by a semi-ring is something called distributivity. This is an algebraic property. What it really means is that, it doesn't really matter if I make a decision about the best paths, seeing all my paths, or you, my neighbor, you make the decisions and you tell me what your best path is. It kind of doesn't really matter.
Because we'll come to the same
We'll come to the same conclusion, right? So
Sure.
that's what distributivity is all about. And this thing I told you about, shortest path, then capacity, that has that property still. But when I turn it around, when I do capacity first, and then shortest path, it breaks that property. Okay, and let me just give you an example of why. Suppose I have a neighbor that sees two paths. One's very high bandwidth, but also a very long path, right? And it sees another one with very low bandwidth or capacity, but it has a short path. And then I am talking to my neighbor over a very low capacity link. So my neighbor picks that high capacity, long path, but I see two paths and I say, wait a minute, this is kind of like a bottleneck link. That sort of wipes out the capacity. It's the capacity of both paths is now the capacity of this really lousy link. As far as I'm concerned, both of those paths that my neighbor is giving me have the same capacity because I have this bottleneck link with very low capacity. So I'm going to break ties on the length. Right? I'm going to break ties. I'm going to want that shortest path. But my neighbor picked the longer path because it had higher capacity. But I don't see that, you see. So we're going to be disagreeing about this. Okay? So a similar thing happens in the internet, for example. If I'm a paying customer of a route, of a path, let's say, I'm paying upstream, I'm paying for this route, but my neighbor is a service provider, one of those paths.
Okay, wait. Let me think about this. So. And I'm probably, frankly, for Network Plus, this is probably a little too esoteric to be learning about, but I think it's valuable, right? So, how are we? What's the? Okay, so. Okay. So you have length, and then break ties on. Capacity, right? So you have this, so you have these nodes, right? And say, this one and this one are trying to communicate, right? And then we have what is a very low capacity link here, but then we have, so we have a very low capacity link here, but then we have a very high capacity link through here, right? And really fast, let me I'm doing something really stupid right now, but it's faster than redoing it. Okay, cool. So, if you split ties on capacity, let me get a new color. So let's say you're going for length, right? Length first. That's fine, because say this one prioritizes length and this one prioritizes length, right? It would just go boom, boom, right? So it doesn't matter who decides that, because both decisions are equal, right? Result in an equal path. However, if this one, say this one cares more about capacity and this one cares more about length, it's going to be going like this, and this one's going like this. And that's as opposed to if you prioritize with capacity, right? Why did I say 2? That's 1. And then you go for length. Because... No, wait, why does the order matter? Am I misunderstanding this?
But I see two paths and I say, wait a minute, this is kind of like a bottleneck link. That sort of wipes out the capacity conclusion, right? So that's what distributivity is all about. And this thing I told you about, shortest path, then capacity, that has that property still. But when I turn it around, when I do capacity first, and then shortest paths, it breaks that property. Okay, and let me just give you an example of why. Suppose I have a neighbor.
If you do capacity first, then shortest path.
That sees two paths. One's very high bandwidth, but also a very long path. right? And it sees another one with very low bandwidth or capacity, but it has a short path. And then I am talking to my neighbor over a very low capacity link. So my neighbor picks that high capacity, long path, but I see two paths and I say, wait a minute, this is kind of like a bottleneck link. That sort of wipes out the capacity. You know, it's the capacity of both paths is now the capacity of this really lousy link. As far as I'm concerned, both of those paths that my neighbor is giving me have the same capacity because I have this bottleneck link with very low capacity. So I'm going to break ties on the length, right? I'm going to break ties. I'm going to want that shortest path. But my neighbor picked the longer path because it had higher capacity. But I don't see that, you see. So we're going to be disagreeing about this, okay? So a similar thing happens in the internet, for example. If I'm a paying customer of a route, of a path, let's say, I'm paying upstream, I'm paying for this route, but my neighbor is a service provider, one of those paths it's not paying for because it's their customer. Another path it's paying for, you know, it has an upstream provider. So that path could be, my neighbor would like the longer path because it's from a paying customer. From an economic point of view, they like that longer path. But I see the two routes as, well, they're both provider paths, they're both equally bad in that sense, so I'll pick the shorter one. So we don't agree. There's one thing I should say about internet routing that I've been sort of taking for granted without really making it explicit, and that is 99% of internet routing protocols only, they're traffic insensitive. Okay? That is, they're perfectly willing to route all the traffic along the most congested link in the internet. Okay? In other words, they don't route around congestion.
So this is the traffic difference between,
right.
Yeah.
And so telco protocols routed around things like congestion. But internet protocols have traditionally, there are a few exceptions, but generally protocols like BGP, OSPF, ISIS, and RIP do not route around congestion. That's considered sort of a network, that's done at network management timescales. So a network manager will see, oh, we have congestion over there. Let's adjust the link weights so that the traffic will be spread out more or diverted. The protocol doesn't do that. The protocol just blindly follows those link weights, those statically configured link weights. It's not sensitive to traffic characteristics. And this is because in the internet, those characteristics tend to change a lot and oscillate a lot.
I hate how they talk to me like this. I should really put something in the system prompt to like prevent this. The path is only as fast as its lowest length. Since your neighbor prioritizes capacity, they'll pick path A and tell you about it. They likely discard path B because to them it's inferior. Now imagine the link connecting you to your neighbor is terrible. When you look at path A through a lousy link that... Oh, I see. Right. Okay, I kind of want to... Is this really about border gateway protocol?
Hey, welcome everyone to a very much requested deep dive session. It's our Border Gateway Protocol, or BGP deep dive. We've done a lot of these deep dive sessions over the past couple of years.
What?
Years or so, we've done them on OSPF and EIGRP and spanning tree protocol, and I think one or two other topics. Wireless. We did a deep dive on wireless not long ago, but this has been requested a lot. So I thought it's time we finally get around to it. Let's do a deep dive into BGP. And to be honest, one reason that I was a bit hesitant initially is that BGP is so deep. This could go on for many, many hours. So I thought, all right, let's do a deep dive, but let's constrain the topics to something around the areas of certification. So we're mainly going to be focused on a NARCI and Encore BGP exam topics. I'll get a little bit beyond that for those CCI candidates out there, but there is just so much to it. And there's a lot of, I call it FUD, fear, uncertainty, and doubt around BGP. I remember when I was going after my very first CCI certification, one of the biggest topics that I was so concerned with was BGP. And I printed out the configuration guide from Cisco. I think it was like 90 pages long. I read that thing from front to back. There is so much you can do with BGP, and we're going to get way deep into the weeds today. But if you've not worked with BGP, no worries, because we're going to start with the basics and then work our way in and get deeper and deeper and deeper throughout these couple of hours or so that we're going to be spending together. But I just want to begin by saying thank you. Thank you for entrusting me with a couple of hours of your time. That's what I'm guessing. 2 to 2.5 hours is my rough guess as to how long we're going to be going through this deep dive. Here are the topics coming up today. For those of you without any experience at all, I want to set a level playing field, and we'll cover some of the basics of BGP.
Be right back for a minute.
BGP? What are some of the characteristics that distinguish BGP from some other routing protocol? We'll talk about, in theory, confederations. We'll talk about route reflectors. That's going to overcome an issue that we have with iBGP neighbors, and we'll define what all that means, so no worries there. We'll talk about how two BGP-speaking routers can form neighborships with one another to exchange that route information. Spoiler alert, it's done very differently than it's done with something like OSPF or EIGRP, and then we're going to do our first configuration of the day. And there's going to be a lot of demos coming up today. The first one, I want to show you that we can take two BGP routers, or two routers, and make them BGP routers with 3 commands. That's it. We can make neighbors and have those neighbors exchange route information with just 3 commands. Hopefully that will give you a little bit more ease if you do have some of that fear, uncertainty, and doubt like I used to have, that this is a very learnable technology. So we're going to get it working basically, and then we're going to start adding on some features. We'll talk about how BGP makes its path selection. If it's got 3 or 4 different ways to get out to the rest of the world, which one does it use? If we're accustomed to regular routing protocols that we might use inside of our company, like EIGRP and OSPF, we might say, oh, we're just going to take a look at the metrics and we'll go with the least metric. No, not at all. It's much more convoluted than that. But after we talk about path selection, we'll talk about an older feature that you might not face in the real world, but you might face on the certification exam, and that's a rule that BGP has that's called BGP synchronization. I'll configure that for you and show you. And between a couple of routers, even we'll see a couple of different ways of take these crazy concepts that are really. You'll get a PDF of those slides for staying around to the end of class today. Now, for those of you that don't know me, I saw somebody fun, so I've reached. I was struggling with some of these BGP concepts, so we're gonna break this into a couple of parts. We're gonna have part 1. And then we'll do a little Q&A break. Now, obviously, we're not going to be able to answer everybody's questions because the volume of people here. Let me do a quick check. We're on some different platforms. Yeah, right now it looks like we're at about 800 people watching us live right now, and so it's just not reasonable to try to answer everybody's questions. A big shout out to Charles Judd. He's behind the scenes right now. He's working chats, so he'll be able to answer some of those. But with 800 people, he probably won't even get to all those questions. So please let me pre-apologize if we don't answer your specific questions. But we absolutely are live. Charles is in the background handling the questions. I'll take a break midway through. I'll try to answer some questions as well. Let's dive in. To begin with, some of the basics of BGP. I mentioned earlier that BGP, the Border Gateway Protocol, that's the protocol that runs the internet. It interconnects the routers running in these internet service providers. And when I started working with BGP, it was back in late.
What? Bro, I didn't know.
late 1990s, like 97 perhaps, like 25 years ago. About 25 years ago, I started working with BGP at a university, and the reason we started using BGP is instead of just having one internet service provider that got us out to the internet, we had two. So we wanted to be able to load balance and control which traffic or which link we used going out and coming in. So we used BGP, and we had peering relationships with them. And our router, I remember looking at the routing table on that router back in like 97, there were about 65,000 routes. We learned the full internet routing table, about 65,000 routes, and that just blew my mind that how many networks are there in the world? But here's a chart, I gave you the URL if you want to keep up to date and check that from time to time. I took a screenshot of this yesterday. This shows us data from earlier in June, earlier this month, and we're over 900,000 routes in the full.
What? It's over. Oh, wow.
The full internet routing table, quickly approaching 1 million. And this is something you just got to know. If you're working in an enterprise environment and using BGP to connect out, there's a lot to know about it. So let's talk about where it plugs in into an overall enterprise network. Here, let's say that we've got this building, and that's our enterprise. For redundancy, like we did at the university, I've got a couple of paths to get out to the internet. I've got two internet service providers, ISP1 and ISP2. And there's one type of protocol that I might run within that building, within my organization. That's called an IGP. An IGP, here's a term for your notes, that's an interior gateway protocol. An IGP is an interior gateway protocol. It runs inside of what we call, another term for you, it runs inside of an autonomous system. An autonomous system is a network under a single administrative control. So the company I work for, let's say, if I work for this large enterprise, we can be assigned one autonomous system to represent our company as a whole. I'm connecting out to one ISP, they have their own autonomous system. I connect out to another ISP, they have their own autonomous system. But within my network, within my autonomous system, I'm running an IGP, an interior gateway protocol. Examples would be RIP, please don't run RIP, that's a whole other story, OSPF, EIGRP, ISIS, the intermediate system to intermediate system. But what if I want to talk outside of my autonomous system? We have another class of routing protocols, and that is EGP. See, everybody has their own autonomous system number now. ISP1, ISP2, my company, we've got different AS or autonomous system numbers. And it's going to be an EGP, an exterior gateway protocol, that talks between autonomous systems. And currently, you'll see that I just listed one EGP, and it's called BGP, the Border Gateway Protocol. Just a bit of a historical trivia for you. Can anybody tell me in the chats, and I'm looking at a couple of different chat interfaces, we've got some people joining us on YouTube, some people joining us through our site, but can anybody tell me, once upon a time, there was another exterior gateway protocol. Can you name it? And by the way, I know there's a few seconds of delay from the time I ask something and the time you hear it. It's like a 15 to 20 second delay. So I'm currently killing 15 or 20 seconds to give you time to type that in. But what is a previously existing, we don't see it anymore, exterior gateway protocol? Does anybody know it? Let's take a look at it. Let's see, yeah. Cheryl was the first one that I saw with the correct answer, and yeah, lots of people coming in with it now. It's EGP. That's right. There was an EGP, an exterior gateway protocol, that was named EGP. That's like having a car named Car. That wasn't very imaginative. But I remember the day when Cisco iOS supported that. I could choose between EGP or BGP. Well, that's gone. That was just kind of a historical note for you. But I want you to understand, please take a note on this. There are two flavors of BGP that we want to know about, and they behave differently, and we'll see some of those different behaviors today. One flavor of EGP is called BGP with a lowercase e and then uppercase BGP. And EGP, that's an external BGP. It runs between autonomous systems, like between our company and our different internet service providers. There's another type of BGP that can...
I should probably make a note for autonomous system. One moment, sorry.
can actually run inside of our own autonomous system. And it's called iBGP. We don't have to run that necessarily. If I'm just wanting to do eBGP out to my service providers, I might not want to do iBGP. I don't have to do that. But some design scenarios, eGP, that's an external BGP. It runs between autonomous systems, like between our company and our different internet service providers. There's another type of BGP that can actually run inside of our own autonomous system. And it's called iBGP. We don't have to run that necessarily. If I'm just wanting to do eBGP out to my service providers, I might not want to do iBGP. I don't have to do that. But some design...
Oh, thank you. Person. Super try 5419. Oh shit. You know me. I think you know me in real life. I don't know who you are. Oh, wow, I see. Okay, hello. Awesome. Yes, I'm studying. I tend to live stream myself studying. Hi. Yes, it's because I find it helps incentivize me to study. If you go to my YouTube channel, you can see quite a few VODs. I was playing awesome music earlier, but now I'm watching a video. Look, I was playing Rugford Zauberg 10. Yes, much love to education.
Design scenarios make that a good thing to do. I did a BGP training years ago for a very large international bank, and they used it pretty much all over the place. They used interior gateway, or interior, or I should say, internal BGP inside of their banking locations. So those are two flavors of BGP, and I want to make a big note of it here. So here's the definition again for your notes, or if you stay to the end, you can just download this. And that is,
Do I have a note for internet service providers? Okay. Do I have a thing for load balancer? Yeah, load balancer. Let's go. Because they help with load balancing between... Oh god, and because I'm using this stupid mouse, I don't have a back button. Majority of BGP implementations are internal because they help with load balancing between ISP routers. With load balancing and... What did this say? To mesh their routers together. Wow, and I can link mesh. I feel like this sentence is like fucked. A majority of BGP implementations are internal. I can't, like, I don't want to be like, because they help with load balancing routers and connecting them with a mesh topology between ISP routers. To load balance routers and connect them with a mesh topology. Making iBGP the most common BGP implementation. For internet service providers, BGP is used to load balance routers and connect them with a mesh topology, making iBGP the most common BGP implementation. Okay, that makes sense.
Internal BGP inside of their banking locations. So those are two flavors of BGP, and I want to make a big note of it here. So here's the definition again for your notes, or if you stay to the end, you can just download this. And that is, internal BGP that runs within an autonomous system, external BGP is going to run between autonomous systems, and they have different levels of believability. Do you remember from some of your earlier networking studies, you learned about this concept called administrative distance? Administrative distance was the believability of a routing source. Well, the believability, and lower is better, by the way. Well, eBGP that's running between our autonomous systems, it is very believable. It has an administrative distance of 20. That beats out RIP and EIGRP and OSPF and ISIS. It's very believable. But iBGP, I've got it highlighted for you on screen, not so believable. It's got an administrative distance of a whopping 200. Basically, if you have an interior gateway protocol that...
Do I have a no on administrative distance? Because how is administrative distance different from like hop count? I'm going to use Opus for this one. Administrative distance is the thing that decides the trustworthiness of the thing that, and something like hop count. Hop count is a metric by which routes are decided, but administrative distance is the thing that decides the trustworthiness of the thing that's using hop count as a metric by which to route certain routes. Is that crazy? But administrative distance is the thing that decides the trustworthiness of the protocol. I shouldn't say thing. Of the protocol that's using hop count as a metric by which to route certain routes. Is that bonkers? At administrative distance. I don't need to have network hardware open. Why do I have so many things open? Okay, so network topology. Kind of like using arbitrary unit. Administrative distance is an arbitrary unit that decides the trustworthiness of a certain Wait, it's assigned to dynamic routes? Would a dynamic route just be something that's Okay, okay, I see, I see, I see. I'm gonna bold these to yes. Okay. Router vendors. This is kind of incredible. Bro. Oh, that's crazy. I love Markdown. That guy who killed himself made Markdown. Well, helped make Markdown. Oh, did I just lie? Oh, I totally just lied. Oh wait, no, Aaron Schwartz and Gruber worked together to create the Markdown language. And Aaron Schwartz is the guy who, you know, facing prosecution. Yeah. Yeah, Reddit guy. Yeah, he made Markdown. You know, like when you, on Discord, when you do the 2 asterisks next to a sentence, and it bolds it, this is the guy who thought up that idea. And then he killed himself. No, I mean, lots of people don't know about Markdown. Well, okay, you know exactly what I'm talking about. Yeah, shout out Aaron Schwartz. The really cool thing about Obsidian is that everything is Markdown based. So like, I have all of these notes, right, on the yeah, so like it's really incredible because everything is like in .md files. So I could just like, you know, go into see, I could just cat administrative distance and everything is like in Markdown. And so everything is local. And so it's really nice because I'm able to like, you know, I have a NAS server here and I'm able to just like have all of my notes like synced to my NAS server, and it's really great because it's all manual syncing. Because if you use something like Notion, it's all cloud based, and if you don't have access to the cloud, you can't access your notes. But like I can disconnect from the internet, and of course, you know, the live stream would stop, but I would still have all of my notes locally. And it's actually cool because you're able to set up automatic syncing with a plugin. Like there's lots of you have all these community plugins. It's a really great note taking app, and then you got a cool graph view. Check this out. See, look. And then you get like a graph of like all your different notes, you know, and how they connect to each other. And you can like move them around. Yeah. What was I doing? I was on BGP. What was I doing before? Administrative distance. Right, okay. Yeah, shout out Aaron Schwartz. And fuck JSTOR, dude. Whoa, that happens sometimes. Have what? JSTOR? BG, oh, that's funny. Awesome. What do you, okay, wait, what do you mean? Are you making a joke? What do you mean? I said, what do you mean? And you said, thank you, Leo, because of the stream delay, and you don't know what's coming. You don't know that I'm gonna question. Oh, yeah, I see, okay. Yeah, that's what I thought, but Yeah, awesome, thank you. And it's so funny because this type of guy doesn't exist anymore. Like, there is definitely a, I was speaking to Chester about this, like there's definitely a type of, there was definitely a type of guy, like pre-2016, where like the dominant sort of internet ideology was one of like weird, like sort of libertarianism and like freedom of information, you know? And it's interesting because, you know, come around 2016, that sort of changed, you know? And this was sort of a, not to like, you know, use this person's death as like a rhetorical tool, but, you know, Aaron Schwartz's death also sort of coincided with the death of this ideology, this sort of weird like gray tribe Scott Alexander coined the term gray tribe, but this sort of like gray tribe ideology that like, does it have a Wikipedia page? Gray tribe Scott Alexander Wikipedia. Oh god, no, it's just showing Slate Scar Codex, dude. Gray tribe? Is there anything here? It's over, dude. But yeah, people actually... See? Lore. There's some lore here. It's like the same sort of thing, you know? Oh my god, why do people... Yeah, why do people associate this with Luigi Mangione? I don't know. Anyway, well, yeah, it's because Luigi Mangione was like sort of a rationalist. Like he was like also this type of guy. Like Aaron Schwartz and Luigi Mangione are actually very similar ideologically. Oh, anyway, so the reason I had mentioned the you know, freedom of information type thing is that a lot of these same tech guys, Tor Parsons. Yes, I do know Tor, of Tor's Cabinet of Curiosities, the goat. The goat, he talks about Bell Labs, and he talks about, yeah, I know Tor Parsons. I've been watching Tor Parsons for a while. Yeah. He is the goat. He really is the goat. Yes, you get it. It's actually kind of funny, because I got into rational. I have a little. I have a bookmark. I got into rationalism because, and like less wrong shit because of Tor Parsons. Like this video he had made. I had watched it when it came out, and I was like, wow, these people are awesome. And then I looked into Less Wrong, and then I looked into Gray Tribe, and I realized that Aaron Schwartz and Luigi Mangione are actually the same guy. And so there was sort of a connection there. But anyway, the interesting thing about this is like a lot of these same like sort of Gray Tribe, like freedom of information, like Aaron Schwartz type guys ended up, you know, founding a lot of these AI companies. Yeah, Tor killed the healthcare guy. That's actually what they don't want you to know. Yes, a lot of Aaron Schwartz-esque guys ended up founding healthcare companies, AI companies. And an example of this is like if you look up, you know, you look up like rationalist community, right? And then there's effective altruism, right? And some examples of a famous effective altruist is Sam Altman, CEO of OpenAI. So this guy's like rationalist adjacent. Rationalists really care about, or like Gray Tribe people broadly, because Sam Altman isn't like a rationalist, but like, you know, he's a broadly sort of Gray Tribe, sort of an Aaron Schwartz type guy. a lot of these people ended up founding AI companies, and it's interesting because the same sort of guiding freedom of information ideology that Aaron Swartz had that enabled him to want to, release a lot of this JSTOR stuff for free is the same sort of idea that led to a lot of these AI companies just like using a bunch of random copyrighted internet data to create these large language models. And it's interesting because at the time, this was like a very anti-corporate, like very, like a sort of a very anti-corporate position, right? Like there would be copyright abolitionists, and they would talk, like an example of like a very sort of gray tribe YouTuber is like CGP Grey, right? Like he made a whole video. Why did he delete it? Yeah, so this video is 14 years old, this CGP Grey video, and it's called like Death to, for Copyright Forever, the last one day. I think it was called Death to Copyright, and this like anti-corporate position was like, a big argument for it was like being anti-Disney. So people would be like, oh, the copyright extension would increase every time like, Mickey Mouse was gonna go into the public domain or whatever. And it was like a very sort of anti-corporate position to like be anti-copyright. So, a lot of these people were in charge of these AI companies, and they were like, oh, we need training data. We're just going to use publicly available information online. We don't even believe in copyright. We don't believe in intellectual property. We don't believe in copyright. We're anti-corporate, right? It's like a very, cool anti-corporate thing to be anti-copyright. So we're going to use all this training data. And the thing that had happened is these AI companies ended up being very successful. And it just so turned out that everything sort of flipped. And yeah, these guys, they are awesome. And so, I know you're probably being ironic. But the interesting thing is that because these AI companies got very successful, the sort of dominant corporate ideology actually became one of being anti-copyright. Like these people who were originally in a very anti-corporate position went into a very pro-corporate position because the ones in power became the ones who were anti-copyright. And it's really interesting because it used to be like an anti-corporate thing, and now it's a very pro-corporate thing. When nobody's positions have changed, it's just like who's in power has changed. And so the people who are like anti-power structures are now like super pro-copyright. And like you see these left-wing people on Twitter, and I don't necessarily disagree with these people, but you see these left-wing people and they're like super pro-copyright, super pro-intellectual property, when these exact same people would have been anti-copyright even 10 years ago, Okay, I think it's cool that you're being unironic, Rosemary, because I too think this type of guy is very cool. And that's why I'm on Less Wrong, which is like a sick form in a good way. But and Less Wrong is full of these guys. So is yeah. That's what I'm trying to get across. That's what I'm trying to do. I think there's a lot of value in this sort of type of community. Yeah, exactly, right? Yeah. Thank you, Rosemary. That's a very good faith way of looking at it. It's all love. Man, a guy who's 26 in 2013, how old would he be now? That would be 2025 minus 1986. Man, this guy would be 39 now. How old is Larry Page? Heart hands emoji. Oh, Larry Page is 52. I see. It really is a loss. Aaron Schwartz is a really cool guy. It's kind of a shame that his work turned into like a PSYOP website. But yeah, I'm pretty sure a big reason why Markdown was created in collaboration with this guy was to like make making posts on Reddit a little easier, right? Oh, I totally lied. When did Reddit come out? I think Schwartz... we both had the wrong idea, Rosemary. It appears Reddit was founded in 2005 and Markdown was made in 2004. But yeah, it does look like it was made like with the idea of making like a really good structured text format. I think the Schwartz case is so sad and such a loss to that kind of culture you were talking about. That is true. Like sort of what I was saying before, like it's super... The death of Aaron Schwartz is like super indicative of like the death of this type of community. I think around the same time, I could be wrong. I think we read the same thing. Oh, what? 2021? What? Okay, never mind. Okay, wait, so, okay, Less Wrong 2.0 was created in 2017, so there was definitely a very real, like, I will not be That's true, that's true. Well, it's I think I haven't been able to speak to you because I've been off Instagram, so I think this way we're able to speak about this is really interesting. Yeah, so like around 2013 to 2017, there was like Less Wrong kind of died, like around, you know, the mid 2010s, and you know it sort of came back. There's a big resurgence. God, you're on Twitter. You know this guy? Do you know this guy? Are we on the same? Like in the same Twitter areas? Because God, this guy's just the worst poster of all time, dude. I hate you. Tor double upload, really? Oh wow, double upload. That's incredible. God, no, this guy. Did he, hold on. Okay, I can't, live tour update, yeah. This just in new tour update. Yeah, God, this guy's so... Oh my God, I mean, you know, it's nothing but love, right? But like, this guy's very, You're fine. I think you can be. I don't know if that's, you know, yeah, banned for dating a chaser. God. No, this guy's so... He got really popular recently because he said that he would, he's not... I don't know if he's like a chudda traditionally, but he did say that he would kill for his child. And then there was like a discourse started that was like, guy who just wants to kill people, I would kill for my child. And then people were talking about like whether or not like you could say... Do you know that? Were you there with that discourse? I don't know. It is chud adjacent, and I think he is kind of a crazy person. Like, hold on. Let's go on X. Let's go on X, the everything app. Hold on. Yeah, okay, exactly. It was this guy. This guy said he would kill for his child thing. Yes, it was this guy. Jeffrey Epstein. What? Bro. I didn't know this. So for some lore, Less Wrong was founded by this guy by the name of Eliezer Yudkowsky. And this guy's fine. Like he had a good Lex Friedman interview. He's like broadly a pretty smart guy. But before he founded Less Wrong, the forum, like the rationalist internet forum, he made what was it? Yeah, he founded the Machine Intelligence Research Institute, and it was like, you know, this guy's been talking about AI safety since, like, you know, the year 2000. He's been talking about this for 26 years, and you know, Miri, I had no idea that Miri had a $50,000 donation from Jeffrey Epstein. That's crazy. Why did the Rational Wiki have a page on Jeffrey Epstein? Guy who reads the Rational Wiki page on Jeffrey Epstein, dude. Oh my god. And Rational Wiki has nothing to do with rationalism, I don't believe. Like, it's sort of this is sort of like a lolcow, like, website. You know, not to use that phrase, but God. But yeah, Miri does some pretty interesting. Nate Soares? Don't I know this person? Oh wait, he co-wrote this book. Hold on. Yes, he co-wrote this book on AI safety, which. To be fair, yeah, they made this book on superintelligence, and Hank Green actually interviewed him. Yeah, see, yeah, this was like a really good interview with Nick Soares, who wrote this book. I know it's not about that, but I like pre-2016 culture got fractured, and one of the splinter types of guy you see, like, is a libertarian, righty, rationalist kind of guy, even if they don't self-ID as rat. That's definitely true. It's like a very... It's so weird, because it was such, like, a pungent ideology. Like, it was the main... Like, it was the main way people viewed things on the internet, like a very sort of, like, pro-market, like pro-social freedoms, like, yeah, like, it was everywhere, right? And it's so crazy because nowadays people, like, don't even know what you're talking about. Like, they don't even think that this type of guy exists, which is crazy because, like, tens of millions of people were this guy before 2016, you know? It's just so crazy. Is this website still up? Oh man, very sad that the TLS certificate expired. That's very that sucks. Becoming the dominant. Yeah, for real. Like, I remember, well, I don't remember, honestly. Hold on. I have to scratch my leg. Wait, Quinn Norton? Like the antivirus? Fellow who lives in Luxembourg. Whoa. Yeah. I can't imagine being Aaron Schwartz and dating this person. I see. Bro. Was this guy part of, Yeah, okay, yes, he was. Okay, I can't... Okay. I'm not gonna get too far into that one, but, this was a very sort of... You know, this guy... There was a sort of, this person was just right-wing, but there is a... Do you know, like, Nick Mullen? There was, like, a hacker group full of, like, Nick Mullen-esque guys who ended up being pretty influential on the internet. Yeah. Yeah, like the podcast. It's funny, a lot of, like... I don't want to, like, go onto this Wikipedia page because it just, like, has the N-word a bunch. But, yeah, these people were quite influential. Bro. And it's so crazy because, do you know about, you should try to articulate it, what you're talking about, like, when the culture had shifted. But it was, like, it was a very real thing. And it's kind of a shame. Do you know about, I think... This talk is really good because it talks about how, I don't know, what's the dude, do you know what I'm talking about? It's Innuendo Studios talked about this somewhere, but he talked about how Steve Bannon, hold on. Steve Bannon's a crazy like, he's like one of the most interesting guys ever. Yeah, so like, check this out. Yeah, so he was part of this Hong Kong company called Internet Gaming Entertainment, where they just like paid people to do like gold farming and WoW, and it enlightened him to, you know, Bannon became interested in the game's online community, describing its members as rootless white males who had a monster power. Through Breitbart news editor Milo Yiannopoulos, who Bannon recruited, Bannon realized that he could activate that army of gamers and internet trolls, adding in 2017, they come in through Gamergate or whatever gets them turned on to politics and Trump. So, like, the crazy thing about Steve Bannon is he was kind of like an architect of this cultural shift, you know, through Gamergate, toward this, like, you know, this dominant internet ideology, like, changing so much. The craziest thing about Gamergate is just how intentional everything was. Like, everything was super, super intentional. And a lot of it was like from this guy, a lot of people on his team, people like Milo Yiannopoulos. And you actually see that on yeah, so this is like, you know, in 2014, and I believe this is 1 month after Gamergate. Yeah, August 2014 through 2015. So this is like this is like right... Yeah, exactly, Rosemary. So this is a kind of a reductive blog post that talks about how like, and I do think it's partly true about how like a lot of political membership isn't really rooted in any logical, sort of ideological framework. It's all just sort of social groups. Like, you know, this is kind of a weird thing to say because you don't really hear it articulated, but you know, I think the reason I'm progressive is because I live in Seattle and everybody I know is progressive, right? Like if I was born in like Tennessee and I was raised in Tennessee, I would probably be right wing, right? And so, you know, that's just sort of the nature of, you know, and I try and everybody's sort of working back, right? Like everybody's already in these, you know, political social groups, and everybody sort of works back to like you know, try to justify like their positions, right? And I do think, you know, broadly progressivism is like more rooted in facts than like whatever right-wing ideology is going on. Though I am a little sympathetic to like, you know, efficient market theory and such. But anyway, so this group, this post is basically saying like, oh, you know, when people are in these political groups and you know, they say things that are political, they're more just like doing social signaling. It's like all social signaling, really. And it's, you know, broadly true. It's a little reductive because I think there are like a lot of ideological, like even if somebody is, I'm going to get back to Gamergate, but the idea is that like even if somebody is acting on behalf of like their social groups, they're still sort of an ideological actor, but the reason why they're doing it is like faulty, right? I mean, they're doing it to signal to their social group, but even if they're doing that, they're still like sort of acting like an ideological actor, and it results in like the same outcomes. But anyway, oh god, terrible thing about this website is like it loads all of the comments at once, and so you can't scroll with like. Yeah, exactly, right? I mean, people baseline believe things, and then, like, when challenged, they sort of justify their beliefs going backwards, right? Like, nobody really has, like, a baseline philosophical framework through which they view the world. Like, nobody naturally thinks, like, oh, I'm a utilitarian, and I want to maximize, you know, the maximum. Like, nobody thinks like that, right? And so, by default, right? And so, anyway, was a gamer, right? Yeah, so something really crazy about this post is that it's so of the time. Like I wouldn't say it ages badly. Like I'd say it ages pretty well, but it ages well in that it's very dated. Like you can read it and you're like, wow, this is really made like 1 month after Gamergate started. And an immediate example of this is like, people talk about this thing about like, oh, gamers are misogynist, and he's like, oh, do they mean the 52% of gamers that are women? And it's like, no, like dude, like this person doesn't realize that he's like espousing ideas that were like mainstreamed by this guy and his team. Like it really was like the craziest thing ever. And this sort of like all these weird psyops online like is what elected Donald Trump in like 2016. Like people were broadly, you know, disaffected, but like I don't know, like there was a lot of turnout that wouldn't have been there if the entire culture online hadn't completely shifted, and there weren't enough like white blood cells to like fight against these you know, ideas yet. It was like language and discourse designed to make, yeah, like, and people talk about Do you know who Flesh Simulator is? He's on Twitter. You might know him, but do you know who Flesh Simulator is? He made a video, yeah, how to conduct a PSYOP, right? And he made this video where he essentially trained a large language model on like this guy. He disliked all of his Twitter and Reddit comments, as well as like his private posts in a Discord server. Like Anita said Anita said extremely basic and normal things, and that was blown up into they're trying to make your games lame. Oh, Anita Sarkeesian. I don't, for some reason I think meant like Sweet Anita, like the Twitch streamer with Tourette's. Sarkeesian said basic and normal things. And that, no, you're fine. I should have known what you were talking about based on the context. And it was blown up into they're trying to make your games lame. Direct link to Gamergate in the modern right, especially to anti-woke crowd. Yeah, that's definitely true. Like, Anita Sarkeesian was doing like some very like basic feminist media analysis, you know, just like on video games. And people were just mad because that just hadn't really happened in such a public way before. And a lot of it was like PSYOP too. But anyway, so this is like a really good video where he makes a where he fine tunes a large language model on you know, this guy's Reddit comments, and he essentially creates like an inverse like clone of this guy to like respond to his own tweets, and it like gets him really angry. Yeah, exactly. Like this is sort of a, you know, of course Slate Star Codex and like Scott Alexander is still around, but like this was like they hadn't known at the time that like there were PSYOPs going on the internet that were designed around making these self-replicating ideas that got people elected. And so something really good that Flesh Simulator talks about in this video is I don't even know what his real name is. That's probably intentional. That he talks about in this video is he talks about how people say like the left can't meme, right? And what a lot of like left-wing people interpret that as is like, oh, we need to make more, you know, images with the text on top. You know, we need to make more images with text that people share around, and we'll hire people and we'll make 40,000 of them, right? When really what people mean when they say that, even if it's not necessarily what they would say when pressed, is that like, oh, like the left wing is broadly bad at making self-replicating ideas. Like as in memetics, like ideas that self-replicate, you know. And the crazy thing was that the right wing really got this down in 2016. Like they got really good at like making these ideas that could spread really effectively through online communities, and like sort of spread in like sort of a self-replicating way. Like the way people would default talk about these things was designed to spread around to other people, right? And so it was just crazy because, you know, even now, 10 years later, it's still like a weird like cultural edge that like a lot of these people have. I don't know. It's just so crazy because so many of the newly right-wing people were existing in the terminally online or gamers, whatever. Exactly, right? And they were able to, you know, with these sort of mimetic units, they were able to with these sort of mimetic eunuchs, that's crazy. With these mimetic units, they were able to mobilize people to vote. It was just so crazy. I know, you know, everything's memetics now. Like, I don't know, especially with like large language models and stuff. Like, I had to get off Twitter because like, I know you probably don't like Destiny, right? But there's this, I don't like Destiny either. The lawsuit stuff is a little crazy. But there's this really good video that talks about the right or reactionary. I don't think that's a vibey, like controversial thing to say. As much as their memes and methods of communicating ideas are meant to stoke that reactionary fire that exists in everyone. Yeah, like, like there's sort of a baseline level of being inflammatory that doesn't exist with like left-wing ideas. And I think that that's super effective in like these online like social media platforms that incentivize inflammatoriness. Like I remember there was a really good thing. Yeah, exactly. The form of social currency. I remember, so one moment. At Grok, why did Facebook remove angry acts? No, there's a, I remember seeing something. I kind of want to, hold on. It's a little embarrassing to publicly use ChatGPT, but it'll ask me, it will give me the answer of what I'm looking for. Wasn't there a study done on let me move this up, on Facebook and how it promoted posts with angry reactions more because they kept people on the platform, like a maladaptive behavior of these algorithms? Think deeply, use your search tool. What am I thinking of? I don't know. There was a very real thing that had happened where Facebook had, I don't know exactly what happened, but I do believe, like, you know when you like something on Facebook and you can do like a heart, or you could do like a like, or you could do like a sad face or an angry face. There was a very real thing. I could have sworn they removed the angry reaction. At Grok. At Grok, did they remove the angry reaction? Okay. Oh, this was the exact thing. Okay, this was the exact thing I had seen. Yeah, so like the way they had set up Facebook to work was they had essentially just made it so they had just made it so like angry actions were promoted more in the algorithm because it kept people on the website for longer. And this was particularly bad over COVID, and they actually ended up reversing this policy because it just spread a whole bunch of crazy misinformation because, like, you know, like the stuff that keeps people on platforms the longest is what makes people angry. And there was a really good, and the crazy thing about this is, like, you don't even need the anger reaction anymore. Like, you don't even need to signify anger. It's just in the algorithm that, you know, if it shows you these types of posts, it'll keep you on the platform for longer. And there's a very real thing. And this was 1 year ago, and you don't really see this exact type of bot that they talk about on Twitter anymore, but I feel like that can be less attributed. Oh, you're fine. You know, I need to do some work here. Yeah. But there's like lots of bots. This is a good video. You should you should watch this video. Yeah, I don't care. I need to do this work.
Is carrying the same route as BGP is carrying. You're going to listen to that interior gateway routing protocol like OSPF or EIGRP. But I did want you to be clear that there are two different flavors. Now let's run down some characteristics. Number one, we've already mentioned. It's an exterior gateway protocol primarily. Yes, you can run it inside, but we consider it to be an exterior gateway protocol that interconnects autonomous systems. And that's what the internet is. It's this big interconnection of autonomous systems. And just like, well, not just like, but similar to OSPF and EIGRP, these BGP neighbors or these BGP routers, they can form this relationship called a neighborship, and that's going to allow them to exchange route information. Now, RIP, for example, it doesn't do that. It just sort of multicasts out, or broadcasts if it's version 1, but typically it's going to multicast out, hey, here's my routing table to whoever wants to listen. OSPF and EIGRP, they're a bit more strategic about that. They send hello messages out to a multicast address saying, hey, I'd like to form a neighborship with any other OSPF or EIGRP speaking routers out there. That's not the way it works with BGP. Yes, they do form neighborships, but not by sending hello multicasts. Can you imagine trying to do that over the internet? No, we're going to statically configure the IP address of our neighbor. Then we're going to go to that neighbor, or whoever owns that neighbor is going to go to that router, and they're going to point to our IP address. So we're pointing to one another's IP address. We're not dynamically discovering one another as neighbors. That's a big distinction. And once we point to one another's IP address, we actually set up a TCP session. If you're curious, it's TCP port 179, but this is kind of like setting up a telnet, or more preferably a secure shell connection between your machine and a host. You get that TCP session set up, and then you exchange information over that session. That's what BGP is doing. It sets up a TCP.
Okay, wait.
Like setting up a telnet.
Oh, dude, my headphones disconnected.
Is carrying the same route as BGP is carrying, you're going to listen to that interior gateway routing protocol like OSPF or EIGRP. But I did want you to be clear that there are two different flavors. Now let's run down some characteristics. Number one, we've already mentioned. It's an exterior gateway protocol primarily. Yes, you can run it inside, but we consider it to be an exterior gateway protocol that interconnects autonomous systems. And that's what the internet is. It's this big interconnection of autonomous systems. And just like, well, not just like, but similar to OSPF and EIGRP, these BGP neighbors or these BGP routers, they can form this relationship called a neighborship, and that's going to allow them to exchange route information. Now, RIP, for example, it doesn't do that. It just sort of multicasts.
I'm actually gonna keep this open. Neighborship. What? Okay, that seems like kind of an esoteric term.
And EIGRP, these BGP neighbors or these BGP routers, they can form this relationship called a neighborship, and that's going to allow them to exchange route information. Now, RIP, for example, it doesn't do that. It just sort of multicasts out, or broadcasts if it's version 1, but typically it's going to multicast out, hey, here's my routing table to whoever wants to listen. OSPF and EIGRP, they're a bit more strategic about that. They send hello messages out to a multicast address saying, hey, I'd like to form a neighborship with any other OSPF or EIGRP speaking routers out there. That's not the way it works with BGP. Yes, they do form neighborships, but not by sending hello multicasts. Can you imagine trying to do that over the internet? No, we're going to statically configure the IP address of our neighbor. Then we're going to go to that neighbor, or whoever owns that neighbor is going to go to that router, and they're going to point to our IP address. So we're pointing to one another's IP address. We're not dynamically discovering one another as neighbors. That's a big distinction. And once we point to one another's IP address, we actually set up a TCP session. If you're curious, yes, they do form neighborships, but not by sending hello multicasts. Can you imagine trying to do that over the internet? No, we're going to statically configure the IP address of our neighbor. Then we're going to go to that neighbor, or whoever owns that neighbor is going to go to that router, and they're going to point to our IP address. So we're pointing to one another's IP address. We're not dynamically discovering one another as neighbors. That's a big distinction. And once we point to one another's IP address, we actually set up a TCP session. If you're curious, it's TCP port 179, but this is...
What? Like inferior protocols. That's a little mean. God, the prose is really nice with Opus 4.5. It's just like way too expensive. Like this whole thing cost me $0.01. Like that's crazy.
This is kind of like setting up a telnet, or more preferably a secure shell connection between your machine and a host. You get that TCP session set up, and then you exchange information over that session.
That's a nice change. Context and pretext? That's sick. Let me make sure I'm using pretext correctly. What? Bro. Good thing I looked that up. That's not what I thought that meant. I mean, I guess it makes sense considering the context in which I've heard it used, but that's surprising. I didn't know it was like inherently a falsehood.
Session. That's what BGP is doing. It sets up a TCP session between two routers, and then and I'll show you the messages that it specifically sends in a moment, but it's going to send messages back and forth, educating one another about what routes are available, which routes are no longer available, what errors do we have, what are our parameters. All that flows over a TCP session. And a little terminology shift for you from what you might be used to with OSPF or EIGRP. Normally, when we're talking about those interior gateway routing protocols, we say that they advertise network routes, and those routes are a network address and a subnet mask, or we might call it a prefix. It's the network, and how many bits refer to the network, and how many bits refer to the host. That's what BGP is doing, but it has a different name. It's called NLRI. And that's network layer reachability information. And it carries the address prefix and the length. The length is the number of bits representing the network. So it does do that. Why don't we call it just a network advertisement? Well, we can send some extra stuff. There's a lot of extra parameters we can also send as part of NLRI information. But I wanted you to understand that we just call route advertisements something different here. Honestly, I still call them route advertisements sometimes, but if you hear that, the acronym of NLRI, yeah, probably talking about a route advertisement there. And another huge difference between BGP and these traditional routing protocols is the way we select a route. With RIP, what is it? Hop count. Shortest number of routers that I have to transit through, that's the path I'm using. OSPF, it's a function of cost. You've got your reference bandwidth divided by link speed, divide, you got your cost. Go with the lowest cost. Is the way we select a route. With RIP, what is it? Hop count. Shortest number of routers that I have to transit through, that's the path I'm using. OSPF, it's a function of cost. You've got your reference bandwidth divided by link speed, divide, you got your cost. Go with the lowest cost.
What did he say?
OSPF, it's a function of cost. You've got your reference bandwidth divided by link speed, divide, you got your cost. Go with the
reference bandwidth divided by
it's a function of cost. You've got your reference bandwidth divided by the link speed. NLRI, yeah, probably talking about a route advertisement there. And another huge difference between BGP and these traditional routing protocols is the way we select a route. With RIP, what is it? Hop count. Shortest number of routers that I have to transit through, that's the path I'm using. OSPF, it's a function of cost. You've got your reference bandwidth divided by the link speed, divide, you got your cost. Go with the lowest cost. With EIGRP, link speed, divide, I'm using. OSPF, it's a function of cost. You've got your reference bandwidth divided by the link speed, divide, you got your cost. Go with the lowest cost. With EIGRP, it's a bit more convoluted, but still, by default, it comes down to bandwidth and delay, and yes, there's a crazy formula, and you can do a lot of stuff with it, but basically it's bandwidth and delay combined. But it's one metric. It's one value, and we say, let's go with the lowest value, the lowest feasible distance, as we call it. BGP is very different. BGP does not just have one end-all, be-all metric that we're just going to go with the best metric. It has several different, they're called, for your notes, they're called PAs, path attributes. These different path attributes can be used.
Okay, let's get a little more atomic. the path attribute is the there's a single piece of information about a path that informs morale.
Used in a sequential order.
I'm gonna do a typing test really quick. Oh God.
We'll talk about the order in a moment, but they're going to be used in order to determine the best path. If the first one's called a weight, and we'll talk about what that means in a moment. But if the weights of two different paths are equal, then we'll go down to something called the local preference. And we keep evaluating these different path attributes until we find one that's not a tie. And oftentimes, we're pretty far down the list before we hit something that's not a tie. But we can manipulate those path attributes strategically to influence which path we take out to the internet, and equally important, people on the internet coming into our organization, which path they're going to take coming into our organization. Can we do that without going into the ISP's building and say, hey, can I reconfigure your routers for a minute? They're probably not going to like that. We're not going to be able to configure the ISP routers. We need to do all that influencing inbound and outbound on our router, and I'm going to do that for you live today. I think you'll really enjoy that one. And as far as categories of routing protocols go, RIP we know is distance vector, OSPF, ISIS. Those are link state routing protocols. I almost got into a discussion of EIGRP. I'm not going to do it. I disagree with a lot of the literature out there. Come see me in my EIGRP masterclass for that. I consider EIGRP to be a distance vector routing protocol. I'll not get into that argument right now. But BGP is a path vector routing protocol. Remember what a vector does, like in RIP? From your high school science or math class. What does a vector give you? It gives you two pieces of information: magnitude and direction. How far is it, and which way do we go, basically? Well, that's what BGP does. It's going to give us a variety of path attributes that tell us how far it is, and we're going to know our next hop address protocol. Remember what a vector does, like in RIP? From your high school science or math class. What does a vector give you? It gives you two pieces of information: magnitude and direction. How far is it, and which way do we go, basically? Well, that's what BGP does. It's going to give us a variety of path attributes that tell us how far it is, and we're going to know our next hop address. That's where we go. But what is a path vector? Well, something that BGP gives us that nobody else gives us, no other routing protocol gives us. It actually tells us the entire path that we're going to be traveling. If I'm going from my network through ISP1, ISP2, ISP3 into some other network.
Wait, what?
It tells me, I can look at my BGP table and it shows me
What? Oh, so it doesn't know like the router level details, but it does know. Okay.
Me that I'm going through this autonomous system, then I'm going through this other autonomous system, and this other autonomous system, and then finally I go into the autonomous system that holds the IP address that holds the IP address that we're trying to reach. And that's why we call it a path vector, because it actually shows you the entire path you have to go. Now, I want to go back and touch on something that's another big point of confusion. A lot of times people hear the term route reflector or confederation, and that kind of makes their head spin because we're not used to that with any other routing protocols. I just want to really simplify this for you, and I'll even set one of these solutions up. But there are two solutions to this issue. The issue is, within an autonomous system, if I've got a bunch of routers and they're talking to one another and they're in the same autonomous system in the same organization, they're using iBGP. If they're using BGP, it's going to be iBGP, which we said was internal BGP. There's a rule, or I guess we could say it's an assumption, and that assumption is we have a full mesh of connectivity. In other words, every router in this autonomous system that's running BGP, it has formed a neighborship with every other router in this autonomous system running BGP. Kind of like I've drawn on screen. We've got autonomous system 65,000, and I've got 5 routers.
I should mention neighborship first. I could have done Shift A or whatever, and then selected the whole thing, and then did YY, and then P for put, right?
Routers. And those red lines, that represents the neighborships. The reason this is necessary is, by default, if one router learns information from a neighboring router in the same autonomous system, it's not going to advertise it out to anybody else, because it just assumes that whoever told it told everybody else, because it assumes this full mesh. The challenge is this just doesn't scale. Here I've only got 5 routers. Here's the math that tells us how many neighborships we have to have a full mesh of connectivity. We can use the formula n times n minus 1 divided by 2, where n represents the number of routers we have. Now in our case, we just had 5 routers, so 5 times 5 minus 1, 4, 5 times 4 is 20, divided by 2 is 10. Yeah, if you were to count those lines, there were 10 neighborships that we had to set up, and that was just with 5 routers. What if we do have this large enterprise and we're running IGP? I mean, at Disney, we had 500, we didn't run IBGP, we had 500 plus routers. Let's say we had just 10 routers. How many neighborships would we have to set up to have a full mesh of IBGP neighborships with 10 routers? Well, it's 10 times 10 minus 1 is 9, so 10 times 9 is 90, divided by 2, 4. We'd have to have 45 neighborships. That's really going to eat into some processor cycles on our routers to maintain 45 neighborships. So we've got 2 solutions, as I mentioned. We've got confederations and we've got route reflectors. Here's the idea behind a confederation. We still have our overall autonomous system with the 5 routers that I showed you a moment ago. We still have autonomous system 65,000. But what we can do is go inside that existing autonomous system, and we can create a subset of an autonomous system. We'll call it a sub-autonomous system. And this sub-autonomous system is going, notice that sub-autonomous system 65,001 on screen, it contains 3 routers, and yes, they have to have a full mesh of connections. Every router, R2, R1, R4, they have to have a direct connection to each other, and they do. And then I created this other sub-autonomous system, 65,002, going between R3 and R5, and they're directly connected. But you see the beauty of this? Instead of everybody connecting to everybody else, I just have to have my sub-autonomous systems connect to any other sub-autonomous systems. So I've just got one link. That connection between R4 and R5, that is interconnecting my two sub-autonomous systems. So this gives us, using confederations, a full mesh of connectivity virtually. Now, by the way, these sub-autonomous systems, they're not going to be advertised to our neighbors outside of our autonomous system. This is just something going on.
Oh, okay. Okay. Be right back for a little bit. Oh, I left my microphone on again. It says autonomous up there. I could have just copied it. I'm actually gonna do a little piracy here. Ugh, really? I love doing this, even though it's such a waste of time. What? Or wait, oh. Wait. That's okay. I always find the bullet point with the image to be a little ugly, but what can you do?
Using confederations, a full mesh of connectivity virtually. Now, by the way, these sub-autonomous systems, they're not going to be advertised to our neighbors outside of our autonomous system. This is just something going on within our autonomous system, but it's a pretty clever way to do it, I think. There's another way that I prefer even more, and I'll actually set this next one up for you in the live interface in a moment, and it's called a route reflector. You've got these same 5 routers in your autonomous system, and you just designate one of those routers, let's say it's R1, will designate R1 as a route reflector. And here's what a route reflector does. Let's see that it gets an advertisement in, an NLRI information from R2. Well, when it gets that, it just like a mirror, it's going to reflect that advertisement out to everybody else in that autonomous system that's using it as a route reflector. I think that's pretty elegant. We just point, there's like, it's kind of like a designated router. I never thought about that, but it's kind of like a designated router in OSPF, isn't it? You've got one keeper and reiterator of network information. That's what the reflector is doing. It gets the advertisement and it reflects.
I hate this mouse. I mean, it's better than my stupid wireless logic device where the scroll wheel doesn't work, but I'm really excited for my Keychron M5. Grow, that's 48. Crop to selection, and then export as... Okay, cool. Thank you for telling me. Look, this is you right now. Hold on, check this out. Look, this is you. Look, you're right there. See? Hold on. That's you right now. Yeah. Exactly. Take that, liberal. Okay. Thank you. I actually get compliments on them fairly frequently. I'm really, really happy with them. I'm very lucky in this regard. I also I also get compliments about my eyelashes sometimes, and I was on the bus and like the light was hitting my face in the right way, and this homeless lady behind me, she said, "You have great eyelashes," and I said, "Thank you." Wow, that's so wonderful. Thank you. The only thing I do with them is I got a pretty significant like unibrow going on, so I have to pluck between them. Every time I shave also. Like I shave and then I pluck between my eyebrows, but that's the only thing I do. Yeah, you get it. Bro. How are we doing this? Dog, I should really just get a dynamic tiler. It's embarrassing that I have to do this. Okay, there's no way of doing this properly. Cool. I love the textual interface. I'm able to tell this little guy in my computer to downscale images for me. Yeah, right? I'm the only person who uses large language models in a moral way. I think it's fine. I think it's fine to use LLMs. I think it's fine. Okay.
Flex it back out. And again, I'll set this up for you live in a few moments. But still on the theory, before we get into our first configuration, let's talk about how it's like a mirror. It's going to reflect that advertisement out to everybody else in that autonomous system that's using it as...
That's true. I actually am the first ethical AI guy. I'm afraid that's true.
As a route reflector. I think that's pretty elegant. We just point to, there's like, it's kind of like a designated router. I never thought about that, but it's kind of advertisement. One of those even more, and I'll actually set this next one up for you in the live interface in a moment, and it's called a route reflector. You've got these same 5 routers in your autonomous system, and you just designate one of those routers. Let's say it's R1. We'll designate R1 as a route reflector. And here's what a route reflector does. Let's see that it gets an advertisement in, an NLRI information from R2. Well, when it gets that, it just like a mirror, it's going to reflect
This game? Wow, awesome RPG maker. You're getting filtered. That's awesome. I've never really played an RPG maker game. The Omega Ring? What do you know about the Omega? I know nothing about this. Don't look it up. Dog. Why did you ask? That's crazy. Why does this have a Wikipedia page? I see, okay. You're like an MK Ultra victim in this way. I see. Is it like Homestuck? Is it Homestuck in the way it's an OG internet fandom thing? Or is it like pre-Homestuck? Mist? Mist is awesome, dude. It's more of a concept you can apply to like any setting. I see, okay. Not OG Star Trek UI, but you know, it's one of the first things that just caught on. I see. Huh. Right. I actually got an email. Oh, okay. Credit card. It's not actually that bad considering it's just like layer 2 yaoi fandom knowledge. I see. This is so crazy. Right, it's like sort of a broadly applicable thing. Why a link to the Greek alphabet? That's such a strange... What do you mean like the notion was introduced? Okay. I see. That's interesting. Yeah, you kinda got me, you kinda got me off track here. Off. Yeah, I love RPG Maker games. I like them conceptually, but I've never really played them. I did play, Imagine if I get paid on Omegaverse, yeah. On Wikipedia. I did play Lisa the Painful, which isn't an RPG Maker game. What? I guess it is an RPG Maker game. Oh, okay. I guess I have... What? Yeah, I've played Lisa. Fear and Hunger is the one with Dasha, right? What was the one we played where we named the character Dasha? You know what I'm saying? And it was like Peter Thiel's dungeon. Yeah, okay, cool. I should play this game. Really? Wow. That's heavy praise. I don't even know what my favorite game is. Probably, I don't know. I've played Minecraft the most. Probably either Minecraft or like Half-Life 2. Half-Life is awesome. I'm so excited for the new game coming out. Supposedly. There's a really good, dude, I hate this mouse. There's a really good video I had watched. What am I thinking of? Yeah, this is a really good video I had watched by someone named Moidbun. I didn't. By someone named Moldbun, sorry. I thought that said Moid. Yeah, this is a really good video about Dr. Breen and how, if not for Dr. Breen, like frankly, humanity probably wouldn't be existing, probably. Yeah, this is a good video. And it was so irritating because so many people in the comments like didn't even take him seriously. Like, I don't know, like, Breen is sort of a good guy in that, you know, yeah, right? Like, he was the guy who, you know, negotiated on behalf of the UN with the Combine to, like, save humanity. Yeah, for real. Definitely. And it's really interesting because something that was mentioned in this video was something about Moidbun. Something really funny though, something really interesting that was mentioned in this video was how, like, right before you kill Breen in the Citadel at the end of the first Half-Life 2, I guess, is that, like, oh, you need me. Like, you need me, talking about, like, his ability to negotiate and speak with the Combine, like, the advisors. Because it is true, like, I don't know, I mean, after you kill Breen, it's sort of a race against the clock on, like, how far the human resistance can get before like, even more Combines start invading. Like, it's sort of a gambit, right? Like, you see, like, from the portal storms, you see all of those advisor pods, right? That's their technical term. Yeah, right. Like, you see all these advisor pods show up everywhere, like, after the death of Breen, because they're trying to invade Earth more. It's hard to imagine because it's been decades, but you're right. Half-Life 2 to Episode 2 takes place in, like, the span of, yeah, right? Like, yeah, right? Like, it's nighttime in Ravenholm, and then it's, like, the next night by the time you're going up to the Citadel and you see the whole city, right? You see City 17. So, God, yeah, to Episode 2, it really was a race against the clock. I hadn't realized just how short of a period of time it is. It's so crazy. It's so, like, I love the Half-Life series because of how few time skips there are. This is a really well shot video too. I don't even know how he did this, but there were, like, I don't even know how you would go about doing this. Oh yeah, he also said, he also said that, like, Breen isn't bald. Like, that he actually talks about, like, the state of his hair throughout the series, and that was actually kind of a weird detail. But yeah, very good video. Oh yeah, and he talks about George Bush. Breen was absolutely right, in that he was the only human authority able to bullshit the Combine, like, more than half of anything he knows. He knows he's full of shit and on borrowed time. Yeah. And, like, I think one of the big reasons why Breen was able to negotiate on behalf of the, humanity with the Combine was that humanity had, like, I think Black Mesa had figured out teleportation, right? And he was using that as sort of a hedge, and he was using that as a hedge against, of course he prioritizes himself when that falls apart, but he knows more than anyone. Yeah, right? Like, I don't know, I mean, Breen wouldn't be in power if he wasn't, like, a smart guy, you know? It's really interesting. Yeah, right? Like, he wouldn't have been the administrator of Black Mesa. Yeah. And dude, I don't know. Like, was Breen really that evil? Like, I don't know what else he could have done. I guess what he could, yeah, like I don't know. Like, I feel like the only thing he really could have done is not put that like special crystal into that machine at the beginning of Half-Life 1, because that crystal was put in there like by G-Man, right? Like that I think more than anything he's selfish and cowardly, but also that resignation, he was able to make something work. Yeah, that's true. That's true. Like I feel like as long as it results in like humanity not going extinct, I feel like anything, like obviously fighting against the Combine wasn't going to be working, right? I mean, they called it the 7-hour war, right? And like a third of humanity died or whatever. Um, yeah, right? Like, I would rather have humanity be sort of like eternally enslaved than have humanity completely die. And that's sort of the gambit that Breen had to make. Yeah, exactly. Oh, dude, I really want to play Half-Life 2 Survivor. Do you know about this? It's like number 2 on the iceberg chart, you know what I'm saying? Yeah. Like, this is so crazy. Wow. Yes, this is awesome. This is crazy. Yeah. Okay, I will watch a video, but one moment, my mom is home and I have to say hello to her. Oh, it's the same guy. Wow. It's crazy they have the bowl squid. Oh my god, and they have the... That's so crazy. They have the cremator, dude? That's crazy. And the old stalker texture. Wow, Slava Ukraini, truly. Why? Yeah. Winning bid of $2. That's so crazy. Wow, that's really incredible. And my parents are leaving to go to a restaurant now, so I'm gonna, he died, wait. Who, the YouTuber? Oh, yeah, okay. Yeah, at the end of the video he did die. That's true, that's true. This person makes such awesome videos. Okay. Okay, I'm gonna finish up this route reflection thing, and then I'm probably gonna be done live streaming for now.
That advertisement out to everybody else
Because I've been streaming
in
for
that
4
autonomous
hours.
system that's using it as a route reflector. I think that's pretty elegant. We just point to, there's like, it's kind of like a designated. There's another way that I prefer even more, and I'll actually set this next one up for you in the live interface in a moment, and it's called a route reflector. You've got these same 5 routers in your autonomous system, and you just designate one of those routers, let's say it's R1, will designate R1 as a route reflector. And here's what a route reflector does. Let's see that it gets an advertisement in, an NLRI information from R2. Well, when it gets that, it just like a mirror, it's going to reflect that advertisement out to everybody else in that autonomous. Autonomous system that's using it as a route reflector. I think that's pretty elegant. We just point to, there's like, it's It's kind of like a designated router. I never thought about that, but it's kind of like a designated router in OSPF, isn't it? You've got one keeper and reiterator of network information. That's what the reflector is doing. It gets the advertisement and it reflects it back out. And again, I'll set this up for you live in a few moments. But still on the theory, before we get into our first configuration, let's talk about how BGP neighbors are formed.
Okay. Rosemary, I must say I am on Discord more than I'm on Instagram, and I'm wondering if I'll delete your message so then it's not like public in the stream VOD, but I am wondering if you could post your Discord so I can message you on Discord instead of having to message you on Instagram, which I'm off Instagram. Do you know what I'm saying? Okay, awesome. The world is beautiful. Okay, I'll add you onto there, and I'll delete your message after the... Actually, no, I'll just add you now, and then... Hold on. Okay, awesome. Oh, and it looks like you deleted it. Did I delete it? No, you deleted it. Okay, cool. Yes, I'm gonna stop streaming now. Goodbye.